Hi, it's Craig with Robinson Roofing, and today I'm going to go over a ventilation calculation for you. And this video is for contractors and homeowners if you're curious. I'm going to go in high level detail in order to show you how we calculate the right venting. And you may need to do research on your own. It's a difficult thing to do. I'm going to do it on a simple building to show you how it's done, but it's a difficult thing to get a contractor to do it. In fact, I think I'm the only one in my area here, we're here on Camano Island, that actually does the ventilation calculation. According to manufacturers, it's very crucial and critical to have a balanced system. Excuse me. And ventilation is for unconditioned spaces like attics. And there's two components, there's two systems to it. There's intake ventilation, so it's coming into the attic, and exhaust ventilation, which is coming out. And there's multiple different ways to accomplish that. The most common that we have in the Pacific Northwest is intake is bird block. So this is 2-inch square or 2-inch round holes of bird block times 3 per bay. And this garage here is paired with the ridge vent. It's going to be hard to tell what that is, but basically underneath the ridge cap there is a vent called the ridge vent. So we're going to calculate what this intake and exhaust need to be on a 1 in 300 ratio. It may be different for your area. But it's a 1 in 300 ratio, so 1 square foot of ventilation, net ventilation, to 300 square feet of attic space. So I went ahead and just counted the bird blocks, and for simplicity's sake, I round down to use easier math and then more conservative math. So what I came up with on this building is 32 bird blocks. Each bird block has a 2-inch opening times 3, so that gives us 9 square inches of intake ventilation per bird block, which gives us a total of 288 square inches of intake. Okay, that might not mean anything just yet, so, and we might be ahead of ourselves here. So what we need to figure out is, okay, what is the amount of intake and exhaust ventilation do we need for this detached garage or house or whatever you got measuring? So hopefully you can see the math here. Maybe I need to come over here. This building is 26 by 32. And so that gives us an attic space approximately 832 square feet. And if you look here, so what I did was I took 832 divided by 300. That's our 1 in 300 ratio. That equals 2.773. Now we're going to convert that into square inches because that's how intake and exhaust ventilation is calculated, square inches. So we got to convert that. So multiply that by 144. That equals 399.36 square inches. Again, rounding on the conservative side. We then divide that by 2. And that gives us our square inches of required ventilation for intake and exhaust. So that's why we divide it by 2, is that it will give us how many square inches do we need for intake, how many square inches do we need for exhaust to be balanced and up to that 1 in 300 ratio. So what we came up with is 200 square inches of intake and exhaust ventilation. 32 bird blocks on this structure times 9 square inches per bird block gives us 288 square inches of intake. So as long as your numbers are above or at the minimum, you are good. Here's where it gets interesting. How do you decide how much exhaust is up there? Well, in order to be balanced, what you do simply is just take that 288 square inches of intake that we have on this building and divide that by the square inches of whatever product you want to use to exhaust the exhaust the air out of the attic. So if we were going to use RVO 38, it gives you 38 square inches of ventilation per unit, then we would need a certain amount. I calculated based on ridge venting divided by 18 square inches per foot, we need 16 feet of ridge venting. So here's where it becomes interesting for homeowners. And if you're a contractor, please do this differently. Most contractors' answer to ventilation is more exhaust. Let's do a ridge vent. So again, this building is 32 feet long. We only need half of that for the exhaust ventilation to do a ridge vent. How do we accomplish that? We can't just, if you just ran 2 feet of ridge vent and then skipped 2 feet and ran 2 feet of ridge vent, it would look so silly and stupid. It wouldn't perform the right way. So what you need to do is you need to run the ridge vent the entire ridge, the entire length of the building, and then put your underlayment. You put your underlayment, so you cut that channel, you put your underlayment over the entire ridge and make openings as needed. So in this case, what we're going to do is we're going to run a ridge vent over this entire ridge, okay, along this whole ridge, but we're only going to have openings every 2 feet. That'll give us 16 feet of ridge venting, which is what we need for this building. Right now it's just currently open. It's just totally unbalanced, not correct. Again, this is high level detail. I hope to make a more detailed video for homeowners to track this, and maybe contractors too, because it took me a few years to understand, okay, how do we calculate this? Where do we calculate this? And then how do we solve the issues of an unbalanced system? Thank you for watching, and I'll see you next time.